Hello and welcome to this final part of the exam series where we're going through the GCSE Maths exam paper from AQA for June 2018, paper 2. We're up to question number 19. Let's begin. Question 19. Multiply out x with x minus 4 inside the brackets. Circle your answer. Multiply out is another way of saying expand. Now when I'm expanding algebra I tend to use the grid method. Now x is one single item and that's being multiplied by x minus 4, which is two items, an x and a minus 4. And when we multiply these, x times x is x squared and x times minus 4 is minus 4x. So x squared minus 4x is our correct answer. Question 20. The ratio A to B is 5 to 2. How many times larger is A than B? That question is asking us how many times larger 5 is than 2. So in order to work that out, we're saying, okay, 2 multiplied by some answer is going to give us an answer of 5. And to work that out, we can do 5 divided by 2. And 5 divided by 2 is 2.5. So A is 2.5 times larger than B. Question 21. A circle has a radius 4.2 centimeters. Work out the length of the circumference. Give your answer to one decimal place. The formula for the circumference of a circle, so circumference, is equal to pi multiplied by the diameter. There are other formulas floating out there that just use radius, but this is the one that is generally taught in schools. Now pi times by the diameter is the circumference, but we've been given the radius. Now the radius would be going on a circle from the centre to the edge. A diameter is twice that distance to go from edge to edge going through the centre. So if the radius is 4.2 centimeters, then the diameter will be double that at 8.4. So we're just using a calculator now to work out the answer to pi multiplied by 8.4, and that will give us 26.38937829. Always write down the full answer first and then round it to its given degree of accuracy. So it wants us to give this answer to one decimal place, which means we want one number after the decimal point. So the first number after that decimal point is the 3, and then we'll round that 3 according to the next number. If it's between 0 and 4, that next number, we'll keep the 3 as it is. If it's 5 to 9, we'll round it up. The next number in this case is an 8, which is bigger than 5, which means that this answer is going to be closer to 26.4 centimeters. Part B. The circle below has centre O. Draw a sector on the circle. A sector is another name for a slice of the circle, which means we're taking the O and drawing one radius and then a second radius. That is a sector of the circle. Question 22. 2 ordinary fair dice are rolled. Complete the tree diagram. So for the first dice, the probability we roll a number that is less than 3 is 1/3, because the numbers 1 and 2 are less than 3 out of a total of 6 numbers, and 2 out of 6 is the same as the fraction 1/3. So if 1/3 is less than 3, the remaining 2/3 will be 3 or more. And that will repeat itself throughout the entire diagram. 1/3 is less than 3, so 2/3 is 3 or more. 1/3 and 2/3. Part B. Work out the probability that both dice land on a number less than 3. Now this is a combined probability. If you want to work out the probability that two events happening, in which case we roll the dice first and get a number less than 3, then we roll the dice a second time and get a number less than 3, and we want to work out the probability that both land on less than 3, which means we're taking both probabilities that are less than 3, which is the 1/3 for the first dice and 1/3 for the second dice, and we multiply them together. So we're doing 1/3 for the first dice, and we're multiplying it by 1/3 for the second dice. And when we multiply fractions, we multiply the top numbers together, so 1 times 1 is 1, and we multiply the bottom numbers together, 3 times 3 is 9. So the probability that both dice land on a number less than 3 is 1/9. Question 23. Match each sequence to its description. One has been done for you. So 1, 1, 2, 3, 5, 8 is an example of a Fibonacci sequence. Fibonacci sequence is when you're taking two numbers from the Fibonacci sequence, adding them together to give the next number. So 1 plus 1 gives us 2, 1 plus 2 is 3, 2 plus 3 is 5, and 3 plus 5 is 8, and it would continue in that same vein. The second sequence, we've got 1, 2, 4, 8, 16, 32. Now to get from one number to the next in this sequence, we are doubling. We are multiplying each number by 2. So we double 1 to get 2, 2 times 2 is 4, 4 times 2 is 8, and so on. A sequence that multiplies to get from term to term is known as a geometric sequence or a geometric progression. For the third one, 1, 2, 3, 4, 5, 6, to get from one number to the next, we are continuously adding an extra 1. So we're adding 1 each time, and any sequence that goes up or down by the same number is arithmetic. Right, this fourth one, 1, 3, 6, 10, 15, 21, is adding 2, then adding 3, then adding 4, then 5, then 6. It's going up by an extra 1 each time. Now that is an example of what's called a quadratic sequence, but that's not one of the options that we have left. So if you don't know this one, you can actually start eliminating these. So look at the answers that we've got left. So we know that these numbers are not square numbers. Square numbers are the numbers that you multiply by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. The square numbers is that sequence there. So we've got 1, 4, 9, 16, 25, 36 are the square numbers. The cube numbers are the numbers where you multiply something by itself 3 times. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, that's forming this bottom sequence. Which means that this sequence 1, 3, 6, 10, 15, 21 must match with the triangular numbers. Now just to show you what triangular numbers are, they are numbers that will form triangles if you drew them out with dots. So we've got 1, and then 3 can be formed into a triangle with 1 on the top and 2 on the bottom. Then as we make these triangles bigger, we're adding on an extra few dots on the bottom to make it into a bigger triangle. So the next one will start with that same sequence, but it's adding a base onto this triangle, which means we're going to need 3 dots to make it bigger, and then we would have to have 4 dots to make that one bigger still. So they're forming triangles. But if we count the number of dots, that first one has 1 dot, the second one has 3 dots, then 6 dots, then 10 dots, and so these are the triangular numbers. Question 24. The table shows information about the population of a city. The population in 2001 was 420,000. The population in 2011 is 480,000. Liam claims from 2011 to 2021 the population of the city will increase by the same percentage as from 2001 to 2011. He works out population increase from 2001 to 2011 is equal to 480,000 minus 420,000, which is 60,000. The population in 2021, therefore, will be 480,000 plus 60,000, which is 540,000. Does the population 540,000 match his claim? You must show your working. Right, a lot to unpack here, but the main thing is he's increasing by the same percentage. And that's what we need to test. We need to work out what the percentage increase is from 2001 to 2011, find that percentage, and then increase the 480,000 by the same percentage to see whether we get the same answer. Now, percentage increase is where we're taking the increase. So the increase from 2001 to 2011 is 60,000. And we're finding out what percentage of 420,000 is 60,000. The way you do that is we do a division. So we take the 60,000 and we divide it by the 420,000. That gives us an answer of 0.142857, and there's more numbers after that. It's a long decimal. Now that, as a percentage, if we multiply it by 100 to turn it into a percentage, will be 14.2857%. And I'm going to round that for ease of use. I'm going to call that 14.3%. So the increase from 2001 to 2011 was an increase of 14.3%. Now we need to increase the population in 2011, the 480,000, by that same percentage and see if we end up with the same answer as Liam. So to increase 480,000 by 14.3%, you have two options. You can work out 14.3% of 480,000 and add it on, or you can work out a multiplier by adding this to 100% and then calculating it as a decimal. That is slightly more complicated than the method I'm going to use. I'm going to go for the first method, which means I'm going to work out 14.3% of 480,000. In order to do that, to work out any percentage of an amount, we can take the 480,000, divide it by 100, which will find out what 1% is, and then multiply it by the 14.3 to find out what answer that gives us. So 14.3% of 480,000 is 68,640. To work out the final population in 2021 then, is we will take the original 480,000 from 2011 and add on that 68,640 to give us an answer of 548,640. Apologies, 640. Is that number the same as 540,000? No. They're not the same number, therefore the population of 540,000 does not match his claim. Question 25. On 3 days, Ali throws darts at a target. Here are his results. Work out two different estimates for the probability of Ali hitting the target. So, we can basically take any pair of numbers from Monday, Tuesday, Wednesday, or the total, and write it as a fraction of the number of times he hits the target over the total number of throws. So I'm going to choose Monday's probability, so he hit it 15 times out of 20. If you want to simplify that down to 3/4, you can do. I can leave it as 15 over 20, that's perfectly correct. And I'm also going to choose the total and do 54 over 90, which you could simplify down to 3/5 if you wanted to. I'm going to leave them as they are. So there's two different estimates, and you can literally choose any combinations you want. Part B. Which of your two answers is the better estimate for the probability of Ali hitting the target? Give a reason for your answer. Now, the one which has the better estimate is always the one which used the most number of throws. The more times you conduct an experiment, the more accurate an estimate for a probability is going to be. So basically, whatever answers you've got for part A, you choose the one which has the most number of throws. So for me, this is going to be the 54 over 90, and the answer is always because it has more throws. And that's the end of that question. Question 26. Theo starts with savings of £18. James starts with no savings. Each week from now, Theo will save £4.50 and James will save £4. In how many weeks will Theo and James have savings in the ratio 15 to 8? So I'm going to set this up as a table. So I'm going to have Theo and James, and they are starting, Theo starting with £18 and James is starting with nothing. So that's at the start. And then as we go to week 1 and beyond, I'm going to add £4.50 onto Theo. So adding £4.50 will take us to £22.50. And £4 for James. And we are checking whether this becomes the ratio 15 to 8. Okay, now 15 to 8 can be brought up, so it could be like 30 to 16 if we doubled both of the numbers. It could be 45 to 24 if we multiply both by 3. Or we could try and turn these numbers into one of these two. So for example, if we know that James has got 4, if I double 4 I get 8. If I double 22.50 I get 45, which is not the same as 15, so that is not in the ratio. When I go to week 2, I'm adding on another £4.50, which takes us to 27, and adding on another 4, which is 8. Well, 27 to 8 is not the same as 15 to 8. 27 and 15 are different numbers. Keeping going. Number 3, adding on £4.50, it's 31.50, and then to 12. So 12 would be adding half of 8 on top, so adding 4 on, so adding half of 15 is 7.50, that would be 22.50. That's not the same, so it's not the same ratio. Week 4, we're adding on another £4.50, gets us to 36, and adding another 4, which is 16. 16 is double 8, so if I double 15 I get 30. It's not the same as 36. Keep going. Week 5, adding on another £4.50 takes us to £40.50, and adding on another £4 takes us to 20. That's still not in the same ratio. And then finally, week number 6, we add on £4.50 will take us to 45, and adding on another £4 is 24. Remember I said before, if we take the ratio 15 to 8, if I double both of those numbers I get 30 and 16. That would be matching up with that point there, which you could see the 30 didn't match the 16, the 30 didn't match the 36. If I multiply both these numbers by 3 I get 45 and 24, and those numbers both match, so it took them a total of 6 weeks. So that's my answer, 6 weeks. Question 27. The volume of a sphere is 4/3 pi r cubed, where r is the radius. A container is a hemisphere of radius 30 centimeters. So a hemisphere is half a sphere. Sand fills the container at a rate of 4,000 centimeters cubed per minute. Does it take less than quarter of an hour to fill the container? You must show your working. Right, first of all we need to work out the volume of this hemisphere. To do that, we first of all need to work out the volume of a full sphere. So for the full sphere, we're doing 4/3 times pi times r cubed, and r is the radius, which in this case is 30. Once again, that is a calculator question. You can type all of that in individually, or you can do it bit by bit and do 30 cubed, press equals. Then you can multiply it by pi. Then you can divide it by 3 and then times it by 4, and that will give you the answer. So the volume of the sphere is 113,097.3355 centimeters cubed. That's the full sphere. If we want the hemisphere, we need to take this answer and divide it by 2. So the volume of the hemisphere will be 56,548.66776 centimeters cubed. Now we need to work out how long that takes to fill with sand. So it fills at 4,000 centimeters cubed per minute. So we say that every 1 minute it fills up by 4,000 centimeters cubed. So we need to figure out how many 4,000s are in this total volume. You can do that by dividing that answer by 4,000. So we're going to divide that by 4,000 to work out how many minutes it takes. So when we divide that, we get 14.13716694 minutes. And we need to say whether that is less than quarter of an hour. Well, a quarter of an hour is a quarter of 60 minutes, and a quarter of 60 is 15 minutes. So yes, it does take less than quarter of an hour, because 14.137 is less than 15. And the final question, question 28. The length of each side of a regular pentagon is 8.4 centimeters to 1 decimal place. Complete the error interval for the length of one side. So I'm going to draw this on a number line so it can be visible. So we've got 8.4, and that's going in the centre. Now that has been rounded to 1 decimal place, which means that there is a number 1 decimal place down as 8.3, and 1 decimal place up is 8.5. The error interval is showing which numbers would round to 8.4 to 1 decimal place, rather than going down to 8.3 or up to 8.5. Those numbers are found at the midpoints of these sections. So the number in the middle of 8.3 and 8.4 is 8.35, and the number in the middle of 8.4 and 8.5 is 8.45. Now if we reached exactly 8.45, it would actually round up to 8.5, but that's taken care of in the fact that we're using inequality symbols, and so we can be greater than or equal to 8.35. So it's got that little line underneath the inequality to say that it can be equal to that. So if you hit that exactly, it will go up to 8.4, but it has to be strictly less than 8.45. So if you have something like 8.4499999, that's less than that, which will round to 8.4 rather than 8.5. So there's our error interval. Part B, complete the error interval for the perimeter. Now the perimeter is the distance around the shape. Now this is a pentagon. So if I show you a pentagon, that has got 5 sides. Each of these sides can be somewhere between 8.35 and 8.45. So all we're doing to get our perimeters is multiplying these lengths by the 5 sides that would be added together. So 8.35 times 5 is 41.75, and 8.45 times 5 is 42.25. And that is the end of the exam paper for June 2018, paper 2. Goodbye.